this week's content, we may briefly review what we had last week. Okay, so last week we first had a mathematical tour, optimal control, and then we used that tour to solve 3 types of models. So the optimal control is used to solve a dynamic dynamic optimization problem in continuous time. And usually you will have an objective function, and your objective is to maximize something across time. It's accumulated utility or accumulated value across time. And also you will have some state variables that evolve across time depending on your choice. There will be a state variable and there will be a choice variable. The state variable cannot change, cannot jump. They have to evolve according to some law. But the control variable or the choice variable can be chosen by yourself freely. And then we try to derive a useful way. We try to obtain a useful way to solve the model. So we start from the easy to use version, the problem directly. Okay, this is where we start with. And then we show that there is a principle of optimality, which means that if some optimal path is optimal starting from the very beginning, then it must also be optimal starting from some other time in the future. Okay, so that also means that once someone make a plan for this whole dynamic path, it will not regret later on. Okay, so it's time consistent. And then we use that principle of optimality to prove the HJB equation. The main idea is to take first order derivative with respect to time. And then you have the HJB equation. The HJB equation is useful to derive the infinite horizon maximum principle, which is often used to solve the dynamic problems directly. So we also take derivatives with respect to x and y on the Hamiltonian function. And then we can obtain the first 2 conditions in the maximum principle. The third line is just the law of motion. And the last 2 are the terminal conditions. So basically, we just use one approach, that is to take the derivative with respect to the original problem. We do it twice, and then we can obtain this method. Okay. This method is useful in solving dynamic models. And then we also introduce a more frequently used situation, which is the discounted HJB equation. Sometimes the f function is like this. You have some one period utility f or value f. It also discounts across time, so that it discounts across time, so that we can simplify the HJB equation like this. And then we use the simplified HJB equation to derive the discounted maximal principle. Okay. And then we also introduce the transversality condition, which makes sure that the value of the state will not explode when time goes to infinity. We use this approach to solve 3 models. The first one is Ramsey model. In this model, saving is endogenous, but technology is not. So we could have if we applied all this method, we would be able to obtain some equilibrium conditions like this. Okay. one equation describing the consumption. Sorry, we should move on. It's here. Yeah. One equation describing law of motion of capital, which is the first one. The second one describing the law of motion of consumption. And the third one is the initial condition. And the last one is the transversality condition, which can be interpreted as the terminal condition. Okay. So by using these four conditions, we can first solve for the steady state. In a steady state, we only need to assume that the change rate of capital and the change rate of consumption are both zero. And then you can solve the consumption and the capital from the first two equations. That is the steady state. And in the transitional dynamics, we have a phase diagram like this. Okay, so there is a vertical line and inverse U-shaped line. These two lines correspond to the situation in which the growth rate of consumption and the growth rate of capital are zero. And then these two curves divide the whole picture into four parts. We could use the first two equations here to think about the sign of the change rate of K and change rate of C in these four areas separately. And then we could analyze the possible paths of consumption and the capital. Okay. So now we can we also talk about how these four equations play a role in the phase diagram. The first two equations just give you some idea about how the capital and the consumption should move. So according to the first two equations, you will be able to have some many curves like this, which describe the possible curves of the movement of consumption and capital. And the third one, the initial condition of K tells you where you should start with from the X dimension. Okay, you should start with K0, no matter where you want to go. However, these three conditions cannot give you a unique path because none of these conditions describe anything about the initial choice of consumption. Okay, if you choose a consumption which is very small, then based on some consumption growth rate, you may accumulate more and more capital, and in the end, you will have the capital go to infinity. And if you have too much consumption, you have capital go to the opposite direction. None of these paths satisfy the transversality condition. Even if you only deviate a very little amount from the solution, the correct starting point of C, you will go to infinite far away from the graph in the long run. So that's the reason why we should use the transversality condition to restrict the problem and pin down the unique path converging to the steady state. And we call this situation the saddle path. Okay. So this is standard in your advanced macro. And then we introduced the two-sector AK model. In the AK model, we have one consumption sector, which has diminishing returns to capital. The other one is the investment sector, which has constant returns to capital. And then, because these two sectors are growing disproportionately, one is growing faster than the other one, and in the markets, there will be some relative price of investment goods compared with consumption goods. Because you are producing more and more capital compared with consumption, then the relative price of investment goods will be declining all the time. And we can use all of these no arbitrage conditions. For example, if you choose to reallocate one unit of capital, you want to make sure that the marginal return on capital should be the same across the two sectors. And also, investing the capital across the two sectors the return will be the same. So that will give you some conditions about the growth rate. And in the end, you can solve for the growth rate for everything according to those conditions. Okay. So we only do the balanced growth path analysis because the transitional dynamics is not so easy to do. And also, we have a model of externality. In this model, for each firm, the capital has diminished returns, just as in their production function. Okay. However, we assume that the labor augmented technology A is something related to the aggregate capital stock. If there are more capital in the world or in the economy, then the technology level in general will be higher. That is the externality. Okay. So as a result, the capital has diminishing returns for individual firms, but has constant returns as a whole in the economy. So that's the reason why, even if each firm has some behavior similar to before, like solo model, but in the end, we would have some sustainable growth. The sustainable growth comes from the feature that the interest rate, okay, so the return rate. So interest rate is just return rate minus some. The return rate or the interest rate will not decline in this situation, in this model. In solo model or in the Ramsey model, the interest rate will decline if you accumulate too much capital. Okay. We also know that the optimal path of consumption, the optimal growth rate of consumption is driven by the interest rate. If the interest rate, so we have some conditions like, okay. So usually you will have some optimality condition here in the first equation. So the consumption growth rate is driven by the difference between the interest rate and the discount rate. So if the interest rate is higher, in other words, if the return to capital is higher in economy, then in general, if people are making optimal decisions, they will make the consumption growing faster. And because of this, if the interest rate does not decline in economy, regardless of the capital stock, then we will be able to have some sustainable growth. Okay, that's the difference between the endogenous growth model and the Ramsey model. The Ramsey model, it has the interest rate depending on the capital stock as equilibrium. But the sustainable growth models or the endogenous growth models, they have non-declining interest rate to guarantee the sustainable growth. Okay, so, and also because we have some externalities in the last model, the social planners problem will be different from the market equilibrium. So in the market equilibrium, if all the agents in the economy are making optimal decisions, we can solve for the consumption growth rate. If the firms are making optimal decisions, that gives you some constant return rate. You can solve that. It has nothing to do with some as everything else but the labor. Okay. So given the interest rate, you know the growth rate. That's the growth rate in the equilibrium. And for the social planners problem, you can directly solve the Hamiltonian problem using the optimal control, treating the utility function as the objective function and the law of motion of capital as the G function. And then you can solve for the growth rate of under social planner. It's higher than in the competitive markets because the social planner now can take their externality internalize the externality. Okay, so in the market equilibrium, the return rate is some F tilde minus something. Okay, and in the social planners problem, the minus term disappears. This reflects the feature that the social planner internalized the externality, and you have higher returns compared with the competitive markets. Okay, so that's basically what we have last week. And last week we left over two bonus questions, and it's very good that many of you, more than 25, I guess, of you send me emails. Okay, so let's briefly talk about these two bonus questions. We have one bonus question regarding the assumption of or the market clearing conditions. Okay, so when we derived the Ramsey model, we didn't say anything about market clearing. However, for any model about competitive equilibrium, we must have market clearing. The question was, where is the market clearing condition? Where are the market clearing conditions? Are they implicitly assumed somewhere in the model when we go through everything? The answer is, of course, yes. They are implicitly assumed here. So we have labor and the rental markets. Okay, so when we solve the Solow model, we have the optimality conditions of the firm, which is very similar to these two equations. That gives you the connection between capital and the rental rate, between the capital and the wage rate. Okay, so that is what we learned from the Solow model. However, in the Solow model, the capital here is the capital demand. Okay, so the Solow model, when you solve the firm's problem, you can only get the demand of the firm. Okay, because the firm choose the optimal amounts of capital and the labor to maximize the profits. So the two variables, or the variables on the right hand side, should be the demand side. And in this model, we didn't say anything about demand or supply. That means we implicitly assume demand are equal to supply. We didn't distinguish that. Okay, we just use one variable to denote both. So that's the market clearing condition for the rental markets and the labor markets. And also, there will be some goods markets. We didn't say this in the Solow model, but it exists. So all the goods produced by firm should be demanded by the household. Okay, so that is also a condition. However, this condition is usually redundant, because in this model, at least, the firm has no profits, and the firm gives everything they produce as the income to the household. Okay, the household use the income to purchase something produced by the firms. So as a result, you receive everything from the firms and you purchase everything from the firms. These two, the income and expenditure, should be identical to each other. You use your income to purchase consumption good and capital goods. The capital good is used for saving. Consumption good is used for consumption. So as a result, everything you purchase are from the firm. And you purchase from the firm because you receive money, you receive income from the firm. The income, so the demand side, of the goods markets are the purchase made by the household. And the supply side of the markets is the good produced by the firms. And because the firm makes no profits, so the incomes that the household receive from the firm should be identical to the amount of good produced by the firm. Okay, so when we are thinking about the situation in which the expenditure should be equal to income, then we implicitly make assumption that the goods market clear. So most of students contacting me mentioned that the rental markets and the labor market clearing condition are from here. That's good enough, so I'll give you a full bonus for that. So it is for the first bonus question. And we also have a second bonus question. This question is about connection between a depreciation and steady state saving rate. In this problem, in this model, there are two-way effects from the depreciation to the steady state saving rate. So if you take a look at the first equation, if the depreciation rate is higher, delta is higher, then capital stock in the steady state should be lower. Okay. If the capital stock is lower, then from the last equation, the denominator has decreasing diminishing returns. The numerator has constant returns. So altogether, the right-hand side should be increasing in k. Okay. So from the first equation, we know that higher delta means lower k. That means lower k in the last equation, and also lower saving rates. However, there is one direct effect in the last line. If delta is higher, it directly affects the saving rate. Those are the two-way effects. Okay. So now the question is, which one dominates? Okay. So some students email me saying that there are two-way effects. I only give you half of the bonus because I mentioned that in the class. So you will get the full bonus if you try to do some analysis to think about which one dominates. Even if you don't get the answer, if you do some analysis, for example, you based on the model, take some derivatives, even if there's some mistakes, you still get a full bonus. So now let me show you. So sometimes one question may not have a very clear answer. For example, here, if you don't know the functional forms of k, you cannot say anything more about the connection between delta and s. But in our course, we have learned some special forms of the function little f. For example, little f can be a linear function. It can also be exponential function, as in the Cobb-Douglas production function. So maybe if f satisfies some conditions, some assumptions that we commonly or we often impose, we can say something more about this connection. Okay, so let me show you one way to discuss this. So we start from the last equation. We substitute the first equation into the last equation to eliminate delta. Then you have f prime k star minus rho. Now we should have two terms. You may take two examples. So first you can take the Cobb-Douglas function. In Cobb-Douglas function, little f k is equal to little k to the power of alpha. Okay. So then the first part will be alpha. The second part will be k to the power of 1 minus alpha, k star. Okay. So now you have an expression like this. The whole expression, the steady state saving rate is decreasing function in k star. That means you will have higher capital stock. You will have a lower saving rate. It seems counterintuitive because in this problem we have eliminated delta. Delta is also changing along together with k star. Okay, we just eliminate delta. But from the first equation, we know that when delta is higher, k star is lower. Okay, so that means for our first equation, delta higher, k star lower. And here k star lower, s star higher. Okay, so from this analysis, we know that when delta star is higher, when delta is higher,
then S star is higher for coplaplas. And we may also take the AK production function as an example. Then if the alpha becomes 1, the first term becomes 1, the second term becomes rho. So this whole expression has nothing to do with capital. So the first one becomes 1, the second one the second one becomes rho divided by some parameters. The AK model is like you have A, K here. So this is AK, this is K, so you have A in the denominator. So you will have some constant saving rate regardless of the depreciation or the capital stock. So I show you this example because in many of the situations you may have to think about some particular functional forms to say something more about the question. Okay. In the exams, if there is some question like this, it will be clear whether you can use the functional form or not. Okay. If the question expects you to try some functional form, it will let you know. So don't worry about that. So I also like to re-emphasize one thing. So last week may be too intensive for some of you. If you really have some problem of understanding anything, you can come to ask me directly or come to my office hour. Okay, my office hour, I posted in the Canvas. I guess it's tomorrow morning, but I don't quite remember. So it should be tomorrow morning. I will be in my office every morning. So if you are not able to come to my office hour, you can also make an arrangement with me. You can make an appointment with me by sending an email. Okay. So this week, we will talk about some real or some more advanced economic growth models. So that is the endogenous technology change models. So these models are less than 30 minutes behind the frontiers. These models we talked about this week were published in the year 1990 or 1992. So there are 27-year gap. But the models we learned before has even longer gap. And as we move on and on, we will have smaller and smaller gap to the frontier. Okay, so we really want to understand the process of technology progress or technology change because usually the R&D and technology adoption, these are two activities that can potentially improve the technology. Okay, so R&D is a case when you spend some money to research some project. And technology adoption is that you set up some firms to learn something from other firms. You can copy the mature technology from other firms or from the other countries, legally or maybe illegally. So some the patent that a firm has is something to protect the firm's rights to use the patent to make profits by themselves. But the patent of a firm will expire after many years, like 20 years. Okay, after 20 years, of course, you can use the technology freely, and that's part of the legal technology adoption. And sometimes it's illegal. It's more common in software. When one firm designed a software to help you take more beautiful photos. There will be some functions of the software, the app. And if another firm designed a software similar to that one, it's very easy to have someone similar. If you design the software by yourself, it's very likely that you may have some similar idea to theirs, right? But also, you may learn from theirs. Maybe you are using some apps designed by other firms, and then you get some ideas to make something new, but the new software is very similar to the old one. So it's hard to say which one is new, but this happens quite often. I think WeChat is an example. WeChat, the skin of the WeChat is very similar to WhatsApp, but it's more powerful than WhatsApp. So it's hard to say whether you are adopting their technology or making your own innovation. Maybe it's a combination of two. Anyway, that's just the real world examples. So in theory, we want to understand why do firms innovate? How do firms innovate? What's the role of entry and exit of for economic growth? For example, there are always some small firms trying to innovate something, and then they start their business. Okay, so in the United States, there was venture capital supporting such firms. So that's a powerful engine of economic growth, at least in the United States. Well, that's the entry side. And also the exit side. Some big firms, they make very little contribution to the economy in terms of innovation. Still, those companies may have rich resources, financial resources. They may have personal connection or political connections to banks, right? So that it's very easy for them to obtain funds. And also because they are famous, they could attract talent workers. So for those situations, the existence of such firms may sometimes be harmful to the economy. So sometimes we want to let them die. We don't want to save them if they're in a problem. So these problems are the entry and exit issues for economic growth. We may not be able to get into details of these issues, but the models that can be used to discuss these issues will be based on the models we learned today. And also, sometimes we talk about industrial policy. The Chinese government is like this policy a lot. Well, maybe they have some implicit support for Huawei. Okay, so who knows? Well, you may have some ideas to support this activity, because innovation is activity with a lot of externality, right? So each individual firm may not have enough incentive to make innovation. That's the reason why the government wants to step in. And also, there's a giant organization in the U.S., which is NASA. NASA is a government-owned organization. It does a lot. It has done a lot of research, which is not profit oriented. However, the private industry can learn a lot from their technologies and then make their own profits. For example, the NASA had sent human beings to the moon. During those days, the main purpose of that was to compete with Soviet Union. However, as the Soviet Union collapsed, NASA no longer has any interest to do that anymore. Some people even say that the United States has forgotten how to send people to the moon. Now China is trying to catch up. Well, however, during the process of innovating in the space technology, the whole United States economy has accumulated a lot of technology. Nowadays, some private firms, or like for example, the Elon Musk, he tries to set up some projects to send something to the moon or to the Mars. Well, nowadays it may seem crazy, but who knows? Because as time goes by, it's cheaper, it's easier for private firms to do so. And also, the super rich people may have some interest to do so. They want to have a trip to the moon, or they want to leave something on the moon, personal items on the moon, something like this. So that means at least there is some demand for this. Maybe in the future we could also collect the natural resources from the outside the space. So as a result, the space project may be profitable in the future. But without the contribution of NASA half a century ago, it will be much harder for the private firms nowadays to do those things. So that's the externality can be solved by the government. Okay, so during the 1970s, the Chinese government also tries to send the satellites into the space. But nowadays, these technology can have some returns because you can have the Beidou system to replace the GPS system, at least in the Asian area. And then the other countries which does not have any system like this, they can borrow the service from China and pay some money. So give you some returns. But that relies on the investment many years ago. So, okay, that's the idea of externality. Well, and there are also many rich phenomena or rich mechanisms in the economy. The young firms and old firms may have different incentive to innovate. The big firm and small firm may have different incentive. Some firms produce more externality, some firms produce less. When you think about the industry policy, you may want to take that into account. And also, people talk about the intellectual property rights protection a lot. In the past, well, we get used to use free software. So the Microsoft Word is almost free for everyone, but it was not free. It is not so easy to get a free version in the United States. It's hard to say whether this is good or not, because on the one hand, if you do not protect you cannot protect some of the intellectual property rights, but not the others. You protect your own intellectual property rights, but not the other countries. But it's hard to do that, right? So usually you will protect all or protect nothing. In that situation, if you protect very little, you could easily learn from other countries. But you may also suffer from the losses because it hurts the domestic incentive to make innovation. Let's take the movie The Wandering Us as an example. So the director Wu Fan had invested a lot of money and personal passion into the movie. However, just a few days after the movie was on show in the movie theaters, you could find the movie on YouTube.